Once students have had lots of time to practice with using manipulatives in order to conceptualize subtraction under 1,000 with many different scenarios involving things from students to cookies to snails, any sort of real world connection, we're ready then to take them to using a visual representation. So now we're going to do that second dismissal. With the 468 students we have left, we're going to take away 188 students for that 220 dismissal. So again, we're going to conceptualize it using a tape diagram. 188 students are leaving at dismissal. Some unknown number will be left. We know that if we take the whole and subtract away that 188, we will be left with our unknown. Again, I'm actually going to divide up the board here because we're going to be using visuals this time. I'm going to keep track of my abstract on one side while I do my visual representations. And I left my 468 set up with the manipulatives to help students transition to using visuals. We're actually going to be using base 10 visuals, which look an awful lot like our base 10 blocks. But now we're going to teach students a representation that they can always use, that when they're presented with an assessment, when they're presented with a problem like this in real life, they could pull out a piece of paper and actually do this. So we have in our hundreds place 4 hundreds, 4 squares, and we're going to set those up with squarish shaped things. In our tens place, we have 6 tens, 6 sticks, which we're going to set up kind of looking like tallies. They look like sticks. And then the ones place, we have 8 ones, which we're going to show as dots. And again, really easy to transition from this to this. These look very similar. It's a very natural transition. We can remind students again that this represents 100 individual students. And even though that's harder to see on here, because they've had the chance to conceptualize it with the concrete, we should be able to make that transition, make that leap into understanding. I'm going to follow along again with the abstract. So we have 400 plus 60. There's my 60 plus 8. There's my 8. And again, I'm going to start with the hundreds. That's what students are familiar with. That's what should feel the most natural. I'm actually going to switch to red as we do the crossing out. We're going to conceptualize subtraction here as taking away, as crossing out while we do the visual. It's students moving away from the school to their dismissal. I'm going to start out by subtracting away that first 100. Okay, now we're going to go to the tens place where we have 6, but we want to subtract away 80. We have 60, we have 6 tens, we want to subtract away 80. We know that there are more than 80 students in the school. They are just not grouped into our tens place. So we're going to go, we need 2 more to get to our 8. We need 2 more tens, so we need 20 more. And so we're going to number bond this out. There's the 2 more we need, and we're going to be left with 8 tens. So we'll put those there. We're going to cross these out. We're crossing out this one that we split up, and then these 8 tens are going to migrate back over there. Now to the ones place, we have 8 students in the ones place. We're subtracting 8 students away. That's pretty easy. We're going to cross those out. And now we'll see what we're left with. We're left with 200 in the hundreds place. We're left with 8 tens, or 80 in the tens place, and we're left with nothing in the ones place. So 200 plus 80 plus 0 gives us 280, which we found not using manipulatives this time, but using base 10 draw. We're on to our last dismissal now. We were left with 280 kids. We're going to dismiss 197 at 4:30, and that will give us our answer for how many were left at that 6 o'clock dismissal. As always, conceptualize with a tape diagram. 197 are going home at 4:30. We don't know what our unknown is, but we know that in order to find a missing piece and a part-whole structure, we're going to take the whole, subtract away the part, and find the unknown. Now, students will have had lots of practice using those base 10 drawings in order to understand how to do the removal, how to do the crossing out, how to use number bonds in order to split up the hundreds and the tens when we want to decompose them. Only when they have had plenty of practice with conceptualizing that will we teach them a procedure purely using the symbolic in order to understand. And the reason that we're doing this is because algorithms have been known to break down. These are 7 or 8-year-olds learning how to do these algorithms. They might make a mistake, and when they do, they need something to fall back on, such as those base 10 drawings. And at the end of this, I'm going to show you one more visual representation that students can always use. It's really flexible, and it gives you a way when you tell students to quote unquote check their work, that they can actually do something different in order to make sure that they got the right answer. So we're going to follow these steps for the partial difference algorithm in a very similar fashion to what we did when we were doing the concrete and the representational phase. And we'll connect it to those phases as we go through it. Start out by splitting up the number into that place value. 200 plus 80 plus 0. That's exactly what we did in the abstract while we were using the visual and the concrete representations. Going to do the same thing. We're going to subtract away each piece of the 197 going from left to right, starting with that largest group of students. 200 minus 100, 100 students left. This is now the largest possible part of students that are in the schools. This is the largest possible grouping of students, and we're going to take away from this as we go on. Now we're subtracting away 90, and we're going to use that number bond structure just like we did before. We need to get rid of those 80 students, and then we'll have 10 that we need to get from this 100. So we're going to subtract away 10 students from this largest grouping that we have, 100. Same thing, we have 0. I'll move this down a little bit so it's not as confusing. We have 0 students. We're subtracting away 7. That 7 can go into a number bond of 0, which doesn't help us very much. And then the 7, so we're again going to take away 7 from that largest group of 100. So now we have a problem, 100 minus 10 minus 7. And we're going to do this as leaps. 100 minus 10, well, that gives us 90. 100 minus 7, 90 minus 7, excuse me, that might be kind of hard for kids to conceptualize. They might be trying to do something like subtract the 7 and leave the 9. Hopefully, because they've never been taught the standard algorithm, that won't occur to them. But we can split this up into an easy number bond of 5 and 2. Remember, we talked about how important those 5 and 10 are. Now we can go 90 minus 5 is 85. 90 minus 2 is 83. And we find that there are 83 students left in this last dismissal. So our number bond can be, our tape diagram can be complete with 83 students left at the dismissal. And we know that our equation will be 280 minus 197 equals 83. So now we want kids to check their work. Well, we can invite them then to do the place value drawings, but I want to show you one more really flexible, really easy visual that kids can also be presented with in order to solve addition and subtraction, especially problems. So this is called an open number line. With an open number line, if we're given an equation, so let's say 280 minus 197, we're going to set up a number line The only number I'm going to put on it is 0 because I want to remind myself where my 0 is. Because we have a subtraction problem, we know that we're never going to get any larger than 280. So I'm going to put 280 all the way over here. The numbers will keep going on, but 280 is the biggest number that I have to deal with. The reason that open number lines are so awesome is because they are super flexible. Students can take whatever jumps they want to start out with. So I'm actually going to start out by taking a jump of 80. I'm going to subtract 80 away from that 280. So that leaves me with 200. I don't actually have an 80 in this problem, but I know that this is equal to 80 plus 10. And so I know that I still have 10 that I'm going to have to get rid of at some point, but I don't want to do that now because subtracting 80 got me down to such a nice number. After I get down to that 200, I'm going to do a jump of 100. So that gets rid of here, and then that gets me to 100. And I still have that 10 and that 7 left, which I'm going to do first the 10, which gets me to the 90. And this should look very familiar to what the students already did, so they should feel very good about themselves. I'm going to do the same thing with the 5 plus 2. So subtract a 5, 85, subtract a 2, 83, and look, I have gotten the same number by doing something completely different. So this is a way to use the concrete, the representational, and the abstract in order to get students to really conceptualize a really difficult concept. I hope that this helped to enlighten you about how awesome this progression is, and I look forward to talking with you further.